Hey there, students. Welcome to the CAHSEE Algebra and Functions Part 7 review to get you ready for the high school exit exam. We're going to be going over questions 69 to 80. Remember, the problems can be found on the CDE website. You can just print it and go over them, okay? All right, let's go ahead and take a look at question number 69. It says, which of the following inequalities represents the statement, a number x decreased by 13 is less than or equal to 39. So basically what we're doing here is we're basically translating from words to mathematical formulation or an equation, okay? So a number, we're gonna just keep the order of the sentence in place and then see if we can translate it into math form, okay? So a number x, we have a variable declaration right here, so we can call the number x decreased by 13. What does decrease mean? What operation is decrease? Is it add, subtract, multiply, or divide? Decrease is a subtraction operation, right? So decrease by means that the number x, you're going to take away a number from it. And what number are you decreasing x by? By 13. Okay, so x decreased by 13 translates into x minus 13. All right? So we have x minus 13. What is basically is like equal to, but this one is not simply equal to, this is less than or equal to. So less than is like the L, you know how the L is, less than is just like the L, the same direction as the L, or equal to. When you combine less than or equal to, you're going to have less than or equal to. This is the symbol for less than or equal to. So we're going to apply it here. The number x decreased by 13 is less than or equal to 39. All right, so there goes your translation. And the answer for number 69 is C. All right, let's move on to question 70. Another translation problem. It says, the shopkeeper has X kilograms of tea in stock. He sells 15 kilograms and then receives a new shipment weighing 2y kilograms. Which expression represents the weight of the tea he now has? Okay? So we are going to start with X kilograms of tea, and then the quantity starts to fluctuate, okay? He sells. If you're selling, it's like it decreases the amount, right? So you're basically subtracting. So sell is a subtraction, or is a negative operation, right? So for sell, you're subtracting. So when you sell 15 kilograms, the original X that you had, you're going to take away 15 from it, okay? And then he then receives new shipment. So when you receive something, receiving is like the opposite of selling, right? Or it's like you bought it. So it's like a plus. Okay? So when you receive, you're adding on new items to your stock. In this case, we're adding 2y kilograms. So when you sell 15 and then you add 2y. All right, so this is sell 15, this is receive 2y kilograms. So this is the expression that represents what he now has. So let's see, x minus 15 plus 2y. Your answer for number 70 is D. So just keep track of these operations, all right? Okay, number 71 says divide the number by 5 and add 4 to the result. The answer is 6. Which of the following equations matches these statements? So please keep track of the order when you're reading this, okay? So it says divide a number by 5. So let's declare our variable. Let the number be n, okay? Let the number be n. Okay, why did I choose n? If you look at all the options here, they were all n's, n's, n's. So I just wanted to match, when I'm done, I wanted to match one of my options, okay? So let the number be n. So with the number, we divide the number by 5. So n divided by 5, we can write it like this. And then we add 4 plus 4. The result basically equals, right? This is divide, add. Result basically means equals 9. All right? So remember, it's just a number that's been divided by 5, not the sum. All right? So the answer to that is, for 71, is option B. All right, let's move on to 72. It says, at a local bookstore, at a local bookstore, books that normally cost $B are on sale for $10 off the normal price. How many dollars does it cost to buy 3 books? Okay? So let's look at the unit price, so the price for 1 first, and then we're going to look at the price for 3. Okay, so for the unit price, um, formerly it was $D, right? But now it's on sale for $10 off. What operation does off suggest? If you take off something, you're subtracting, right? So it's like this minus operation. So from the original price, B, this is the unit price, we have $10 off, so which is minus 10. This is the unit price or price for 1. Okay? So the price for 3, price for 3 books is going to be 3 times the unit price, because 3 times 1 is 3, right? So we're going to triple the unit price. So it's 3 times the unit price, B minus 10. We have to put this in parentheses or else our answer will be wrong. Okay? So the answer for number 72 is basically C. All right, let's move on to 73. It says, which system of equations represents the statements below? The sum of 2 numbers is 10. One number is 5 times the other. So let's say let the 2 numbers be x and y. Let the 2 numbers be x and y. Okay? So if the sum is 10, what operation is sum? Sum operation is basically adding, right? And then that means we sum the 2 numbers. So for the first equation, we're going to have x plus y equals 10. And then the second equation says one number is 5 times the other. So 5 times basically means we multiply one number by 5 to get the other. So let's say y multiplied, if we multiply the first number 5, x times 5, we get y. Okay, so 5 times means to multiply one of the numbers to get the other. We could have said x equals 5y, because there's no specific order. It doesn't really matter. But in this cases, y is one that's been isolated. So we need to follow the procedure of the options that we have. So this is a better option to do. So the first equation represents this is the sum, and this is the product equation. So there you have your answer. All right, sum 10. One is 5 times the other. Your answer to this is option number C. All right, let's move on to 74. It says if n equals 2 and x equals 1/2, then what is n times the quantity 4 minus x? So this is a test of your order of operations. Please excuse my dear Aunt Sally. You need to know this when you want to evaluate expressions, or else you ruin the whole problem, okay? So what I'm going to do first is I'm going to substitute. I'm going to take n and put here, and then I'm going to take 1/2 and I'm going to put it in there, okay? I'm going to substitute the values. After making my substitution, then I'll go ahead and execute the order of operations, all right? All right, so let's do this. So we have 2, replacing n with 2, times 4 minus replacing x with 1/2. Okay? Now, in the order of operations, what do we do first? Multiply, subtract, or parentheses. You do the parentheses first, all right? So let's evaluate the parentheses. So we're going to have 2, parentheses 4, minus 1 over 2. So for this one, I 4, I can subtract 1/2 from 4. So let's do this. Let's make this into a fraction, so I can make this 4 over 1, and we can find the LCD. So this is times 2 times 2 to make the denominators the same. So we'll have 2 times 8 over 2 minus 1 over 2. Okay? If the denominators are the same, you can just multiply the numerators, right? So this becomes, you can just subtract the numerators. So you're going to have 2 times 8 minus 1 is 7 over 2. And then when you multiply this, you can make this over a 1. Any number you can place over 1. And then you just multiply across. And then you have 14 over 2. Divide 14 by 2, your answer is 7. So the answer to this is 7. Answer is C. Okay? Another way you could have done this, you could have distributed the 2. That's perfectly fine also, because you're basically dealing with the parentheses in that process. That will also give you 7. All right. Moving along, question 75. This is another order of operations problem. We're going to substitute first, and then we're going to use please excuse my dear Aunt Sally PEMDAS to evaluate whatever resulting expression we have. So h is 3. 3 times k is 4 plus 4. Divide the whole thing by 2 minus 2. Okay? So what do we do first? Multiply, add, divide, subtract. So what we do first is this numerator right here is basically like we can group them in parentheses. So we can evaluate this numerator first before we divide. Alright? So if we look at the numerator, we need to multiply the numerator first. Multiply these two, so you have 12 plus 4 divided by 2 minus 2. Note, because you have a lot of things going on here, it's as though we're grouping this numerator in a parenthesis because we want to treat it simplified as much as we can first before we divide. Alright? So we have 12 plus 4 over 2, and then 12 plus 4 is 16 over 2 minus 2. Alright, so what do we do? How do we do this? We need to divide first before we add or subtract. So 16 divided by 2 is 8. 8 minus 2 is 6. So the answer to number 75 is A. Alright, let's move on to 76. It says, what is the value of 3 plus 5 squared divided by 4 minus x plus 1? This is another, please excuse my dear Antalic problem. Order of operations is what we're going to use here. So you're also told that x is 7, so we're going to take this value of x and we're going to substitute it in there, right? So we'll have 3 plus 5 squared divided by 4 minus, instead of x, I'll put 7 plus 1. Okay? Alright, let's do this. So to evaluate this, let's do the parentheses first. Simplify this parentheses and that parentheses because p comes first in the order of operations, so let's do it. So in here, we have a sum and an exponent. So what do we do first? Do we add 3 and 5 or do we square first? Remember, exponent comes before you add. Alright, so we need to do the exponent here first. So we're going to go 3 plus 25 divided by 4 minus, this is just a direct sum, 8. Let me finish up this parenthesis, okay? So we're going to have 3 plus 25 is 28 divided by 4 minus 8. Now we just have one term in both parentheses. No operation is required to be executed within the parentheses, so we just drop the parentheses. We'll have 28 divided by 4 minus 8. Alright, now how do we do this? Do we divide first or do we subtract first? Look at my order of operations here, going from left to right. You multiply and divide from left to right first before ever you think about adding or subtracting. So these two are grouped together from left to right in the equation. These two go first, and then add and subtract go together from left to right. They go next. Okay, so we have a division here, so that's what we do first. All right, so 28 divided by 4 is 7 minus 8. Now that we have division taken care of, we can now do the subtraction. 7 minus 8 is negative 1. So your answer for 76 is B. Alright, moving along to 77. It says, after 3 hours of travel, car A is about how many kilometers ahead of car B? So we need to be really careful with the scaling of the axis and also the labels here, right? This is the time, our independent axis, and then distance traveled, our dependent axis right here. So we're looking at the change along this axis, okay, because it talks about how many kilometers are ahead, and this is the kilometer unit. Now you notice that we're going by 20s, right? So this is 20, 40, so each tick mark is 10, so this is like a 10, 20, so you have to be careful with the scaling, right, so you don't get yourself in trouble. Alright, so it says after 3 hours, so we're going to focus our energy on the 3-hour line, which is right here, 3 hours. So this is where we're going to look at. After identifying the line, we can just draw a dotted line across it, like that. So it says, how many kilometers is car A ahead of car B? So basically, this is the distance car A has covered right here, 60. If we read it back on the chart, at 3 hours, car A is at 60, And at 3 hours, where on earth is car B? Car B is right here. It's at 40. Okay? It's at 40. So how many miles ahead is car B from car A? It's car A from car B. So all you just simply do is you just compute the difference in the distance covered. Okay? So to do this, let me just write it out so you can see what I'm doing here. So car A covered 60 kilometers, and then car B covered 40 kilometers. How many kilometers ahead is car A from car B? Just simply find the difference, or just subtract. Okay, so if you subtract, you get 20 kilometers. And that's the answer. The answer is C. All right, let's move on to question number 78. It says, the cost of a long-distance call charged by each of the two cell phone companies is shown on the graph below. Company A is less expensive than company B for. Now, if you're looking at expenses, you know that you're looking at costs. Okay, so we're focusing on this right here. We're looking at cost. And the cost increases in this direction. Let me change the color. The cost increases in this direction right here. Right? Increases in cost. If cost is increasing, that means it's more expensive, right? That's what expensive means. And then in this direction, the cost decreases, which means it's cheaper. Okay. All right. So they said company A is less expensive than company B. For the question is, where is company A below quantity company B? So anywhere that company A is below company B, that's where it's cheaper. So we notice that there's an intersection here. Okay. So if you take a look at this chart, before the intersection at 3 minutes, company B is above company A, which means it has a higher cost. So that means company B is more expensive than company A here, or company A is less expensive here. So here, company A is less. And then in this area, company B is less. All right? So the question asks us for where company A is less. So the region we actually care about is this region right here. This region from here, 0 all the way to 3, because that is where company A is less than company B. All right, so company A, see this line right here? This line is for company A. And we can see that it's below company B. Let me use a different line. So this is company A here. It's under company B. So since it's under, that means it's less than. So anything between 0 and 3 minutes, or anything less than 3 minutes, company A is cheaper. So where is that? Calls less than 3 minutes. Company A is cheaper. And then when you go a bit more than 3 minutes, company B is below, which means it's cheaper than company A. So C is the answer for this one. All right, let's move on to the next question, 79. It says the graph below compares the weight of an object on Earth to its weight on the moon. What is the approximate weight on the moon of an astronaut who weighs 120 pounds? So this is the pounds and this is the weight. So if I can identify what 120 is, then I can trace it to the graph and figure out what the weight is. Okay? So for this one, where is 120? It's not shown here, but we can guess. We know 120 is somewhere between 100 and 150, so it's like somewhere around here. Okay? So to make the graph work, we're just going to trace this to the graph, 120 to the graph, and then trace it to the weight. See, it's around this area right here. So a good estimate would be 20 pounds. All right? So there goes the relationship. It's about a sixth. So the answer is 100, and the answer is 20 pounds. All right. Now let's move on. Number 80. It says Amy works as a computer consultant. She charges $30 per hour for her work. Which graph shows the relationship between the number of hours Amy works and the amount of money she charges for her work? So $30 per hour basically means that for every hour, you go up by 30. So which of these indicate that? All right, so let's see which of these indicates a 30-hour increment for each hour worked. I mean a $30 increment for each hour worked. If you look at this one right here, option A, it stays flat regardless of whatever hour she works, it stays fixed. All right, this is constant. This does not indicate 30 hours, $30 for each hour. This one, if you work for 1 million hours, you're still going to earn the same $30. Okay, $30 per hour, that means it needs to go up, okay? This one also means that regardless of how many hours you work, this is a constant right here, constant. So it's not, this is also another constant. This means that for every hour you work, you don't gain, whatever amount of money you start with, you get the same amount. So if you earn $150 for the first hour, if you keep working, you don't get any more money. You stay the same. You get $0 after the first. Initially, actually, when you start working from 0 hours, they give you $150, and after that, you don't get anything more. That's not what the question is saying. Okay, so it's either C or D because you see that every hour you work, you get money. Okay, so which of them is accurate? So if it's $30 per hour, $30 per hour. I don't know why I'm writing percent. $30 per hour. That basically means the slope is going to be, if you rise 30, you're gonna run 1. Okay? That's what the slope of the line should be, rise over run. So let's see which of these equates to that. So let's look at this one. This one says, if I rise 50, I run 1. And then if I rise another 50, I run 2. What is this telling me? This one telling me that the slope is 50, and then that means the pay rate here is $50 per hour. Is that the price we're charging? Absolutely not. We're doing $30, okay? So if you look at this one right here, this is about where 30 is, right? 30 is somewhere here. So you notice that when I rise 30, how many hours? 1 hour, okay? And then when I rise another 30 all the way to 60, which is around here, I get 2 hours. So the slope of this one is 30 over 1. This is exactly what we want. This indicates for every hour you work, you go up 30. Another hour, you go up another 30, and then that pattern continues. So your answer is C. All right, let's move on. Oh, actually, that's it. Anyway, thanks for watching this presentation. Feel free to subscribe so you can get other parts of this video series to get you ready for the CAHSEE. And if you have issues with math, you can feel free to request videos, and I'll be glad to help you out with them. More videos can be found on mathgotserved.com. Thanks again, and have a wonderful day.